Lesson 28, Electrical Power. In this lesson, we only have one objective, which is to calculate the electrical power, knowing the voltage, current, or resistance of a circuit. Now, there is no specific definition for electrical power. It actually is the same definition that you use for mechanical power, the rate at which work is done or energy is expended. Actually, it's more of the second definition, how much energy is expended or used by a circuit in a certain amount of time. Since power is still power, whether it's mechanical or electrical, it's also going to have the same unit, watts. Now, in order to calculate electrical power, we have three possible formulas depending on the information that you know about the circuit. You could either have power equals the voltage times the current, power is the current squared times the resistance, or power is the voltage squared divided by the resistance. Notice that in each one of these formulas, you only know two things about the circuit. One of them is missing. So that's an advantage, because this way you don't need to know everything about the circuit, just part of it. So notice in the first, you are only having the voltage and the current, no resistance. In the second, you have the current and the resistance, but no voltage. And in the third, you have the voltage and the resistance, but no current. You're going to want to put these formulas on your formula card with your electricity formula. You want to entitle it Electrical Power. Also, one other thing to note is you only want to use these formulas when solving for electrical power. Do not use these formulas if you're solving for voltage, current, or resistance. Use Ohm's law to solve for any of those. Now let's take a look at an example. A circuit with a resistance of 10 ohms has a current of 2 amps running through it. What is the power expended to run this circuit? So we start, as usual, by identifying what we're looking for. In this case, power. But now we have to be careful, because we have two types of power, mechanical power and electrical power. So you have to take note as to whether or not you have a circuit. In this case, we do. So we're looking for power, and remember, power is going to be measured in watts, whether it is electrical or mechanical. Now, we just can't put down a formula because we have three possible formulas, so we have to see what information is given. So we see that we have a resistance of 10 ohms and a current of 2 amps. So we're going to want to use our second formula, power equals the current squared times the resistance. We could substitute in our values and get our answer. And remember, it's watts, even though it's electrical power. So now you should be able to do the worksheet. When you do this, you will have some problems that go back to Ohm's law and some which are new using the power.